Hey folks, in this video I'm going to be showing you how to grab some really simple data and turning it into a sweet as graph. And the reason we want to do this is although tables are really good at collecting and storing data during your experiments, they're super boring to look at during reports and presentations and posters and stuff. The last thing anyone wants to see is one of these tables. They want to see something that's going to hit them in the eye with a big kapow. So that's why we want to do a graph. Visually very engaging, it's going to demonstrate a lot of information very quickly. So, really simply, we're going to be hanging out in Microsoft Excel, our good friend, and I've just typed up some random values here. We've got our independent variable here of hydrochloric acid, so that's the one thing that we changed, zero point 0.1, 1, and 2 moles. And then our dependent variable was the rate of reaction it took, the time it took for the reaction to complete. And that was in seconds, so 300, 100, 40. So to start off with, we're going to highlight our time in seconds, the dependent variable, really important. And we're going to go to Insert and over to our graphs over here. And we're going to stick with the 2D columns, just keeping it simple, yeah? And looking at this already, it's demonstrating a lot of information. As we can see, as we increase the concentration, the rate of reaction increases as well. But there's something kind of wrong here. Our x-axis labels are missing. And that's just because something Excel does if they're not inputted. So if we just select the chart and we're going to go over to select data, we get to this page. So FYI, series 1, series always represents the Y values, and these are the columns, I suppose. But our x-axis labels, the horizontal, they're missing. So we're going to input them here. So first of all, we click, so it's flashing, and then we highlight these X values right there. And we click OK. Voila, look at this, beautiful, it's all changed. So, looking pretty good. Final few things is we need to add some axes titles because although the information, we can see something's going on, we need to be very specific. So, x-axis, what we were looking at, this was the independent, this was the concentration of hydrochloric acid, HCl, and in brackets, super important, we always want our units of measure. And I'm just going to put M for mole there. Okay. And for this one was the time for reaction to complete. And that was in seconds. Groovy. All right, nearly done. Let's get rid of this chart title. We don't want it. We're doing scientific reports. We never want chart titles in our graphs. And we're going to copy this. And we're going to go to our Word document over here. It's so much easier to move these things around in Word. Paste it in. All right, so you might be familiar with this, but I'm going to right click and we're going to wrap text and square. And this just means I can shift it around here. I wasn't able to do that beforehand. And this will be our results section. All right, and cool, looking good. Now, last thing we want to do, there's no heading because we removed that chart title. What we're going to do is called a figure heading. So figure 1, they always go underneath. You don't want to put them above. I don't know, it's just the way things are done. We'll bold that. And we want to sort of describe in detail, succinctly, like 1 or 2 sentences, well, what exactly is this graph showing? Okay, so this is showing the effect of increase of concentration of hydrochloric acid with what was it, sodium thiosulfate. So I can put that equation in here if I wanted to be really creative. Those are over these buttons. What was it? Na, I think it's Na2. I'll just copy and paste this. And that was S2 and oxygen. I think was the last one. Groovy. The effect of concentration of changing there we go. Yeah, that makes sense to me. The effect of changing concentration of HCl reacting with, that's what we need, with sodium thiosulfate. I'll leave the sentence structure up to you folks, but that looks pretty sweet. All right, so results section, it's only doing your observations and any data that you found. So we've got a graph from there. you're going to put another graph for your temperature, and then you might want to put any qualitative data. So things that you've picked up or noticed that were out of the ordinary, like smell or God forbid, taste or anything like that. But you definitely saw some things and anything interesting. But now we're going to go to the discussion. I'm just going to show you a few things on how to link these two. Discussion, this is where we we explain why did we get the results, or why do we think what was going on. And one of the key lines that you can use in a discussion that makes things really, really groovy is as can be seen in. I'm not saying that you should start your discussion with this, but definitely have this line in here, as can be seen in, and then in this case, I'm going to say figure 1, as can be seen in figure 1. Well, what did we see? As can be seen in figure 1, as you increase the concentration of reactants, the rate of reaction increases. That's awesome. Such a powerful statement. It says so much because it's linking your results over to here. If people are looking if they're reading a scientific document, they might actually just skip your results entirely. They might just go to a discussion. But when you put this in here, it's providing evidence. It's providing a solid argument, a foundation for your explanation. And it really sets the scene because from here we can say, well, I don't know, like this supports our the hypothesis and the theory of collision theory, collision kinematics, or whatever it was called. That explains how rates of reaction occur and all that kind of stuff. So really powerful sentence. Just to recap, have your axes labeled and change that x-axis. Make sure it's all good. Good luck.